Good morning, class. Here's Module 4, covering Section 5.4, Chapters 8 and 9. Chapter 8, Application of Trigonometry, Polar Coordinates, and Vectors. Plot the following pairs. Well, let's discuss the polar axis. As you can see, if we look at the basic rectangular grid, as far as the polar grid is concerned, the x-axis is considered the polar axis. A rectangular coordinate system gives us a pair with coordinates x comma y, whereas polar gives us a set of coordinates r comma theta. In other words, if you have a point, you can represent it with rectangular coordinate system. X would be the distance from the y-axis, y will be the distance from the x-axis, or with the polar, r represents the distance from the pole, and theta, or the modulus, or the angle that it makes with r. So having said that, in the case of a polar coordinate system, we use a bunch of concentric circles centered at 0, 0. And if we want to plot a point first, we look at all of these angles. We locate theta first. Pi over 6 is here. And then 4, the first circle is considered 1 tick mark, and then you go up 4. So 1, 2, 3, 4 circles. So first you locate the angle. So 1 pi over 2. We are going to locate the angle. Obviously, pi over 2, right up here. And how many tick marks? 1. How many circles? The first circle. Negative to 0, the way the negative works, first you look at the angle. The angle is along the positive side of the x-axis or polar axis. That would be the 0 angle. And if you go 1 tick mark is positive 1, 2 is positive 2. In order for you to go negative, you go to the other direction. In other words, polar, unlike rectangular, there are infinitely many ways to represent it. One would be r comma theta. Then add 2k pi. K is an integer. Or if you want to negate the r, you add pi and then 2k pi. In other words, odd multiples of pi. So, as I mentioned, 2 is to the right, negative 2 to the left. That's how you come up with those points. Now we want to find other polar coordinates for part B, 1 comma pi over 2, where r is still positive, but theta is between negative 2 pi and 0. And obviously, if you want it to be negative, then all you have to do, add negative 2 pi or subtract 2 pi. In other words, look at this 2k pi. So add multiples of 2 pi. In this case, we're going to subtract. And it gives us 1 comma negative 3 pi over 2. And if you want r to be negative, that means you want to make this one negative, then you have to add odd multiples of pi. For example, let's add 1 pi, and we get negative 1, 3 pi over 2. Think about the concept. First of all, this is pi over 2. This is 3 pi over 2. So 3 pi over 2 right here. If it's 1, it's here, but negative 1 goes the other way, and it's the same as 1 comma pi over 2. Now, if you want it to be between 2 pi and 4 pi, all you have to do, go back to the original one. If I add 2 pi, we'll do the job. Gives us 1 comma 5 pi over 2. So that's how the polar coordinates work. Plot the points first. then find their coordinates. So we want to find the Cartesian or rectangular coordinate for this one, 6 comma 150 degrees. So if you look at the grades, the degrees around the circle here, 15, 30, so on and so forth, you can locate 150. Okay. So 150 is here. And we go 6 tick marks. That's how you locate that. So this is 150 and 1, 2, 3, 4, 5, 6. Okay. That's how you locate it. Now, as far as going from one format to the next, polar has coordinates r comma theta, rectangular has coordinates x comma y, and x is r cosine theta, y is r sine theta. However, remember when we looked at unit circle, x is the same as cosine, y is the same as sine, and if the circle was not having a radius 1, it was in a unit circle, then cosine was x over r, sine was y over r. That's exactly the same thing here. So x equals r cosine theta. 6 cosine of 150. 150, if you say 180 minus 150 gives you 30 degrees. This is reference arc, which means all trigonometric functions of 150, they have the same value of the trigonometric functions of 30, except you have to figure out the quadrant and therefore positive or negative. Now, as you know, cosine, this is in the second quadrant, and cosine in the second quadrant is negative. Cosine of 30 is positive square root of 3 over 2, and this becomes negative square root of 3 over 2. So negative 3 square root of 3. What about the y? Y is r sine theta, 6 times sine of 150. And sine of 150 is the same as sine of 30, and it is positive because in the second quadrant, sine is positive. Sine of 30 is 1/2, so we get 3. And so we write down the pairs. 6 comma 150 degrees in polar format is the same as negative 3 square root of 3 comma 3 in rectangular format. What about 2 comma negative 2? We are going to go from Cartesian to polar. And again, let me erase my work. How do we go back? Okay, we're going to locate that 2 to the right, 2 down. Okay, that's the location. And x squared plus y squared equals r squared, tan theta equals y over x, and you have to adjust for quadrant always. So having said that, x squared plus y squared, 2 squared and negative 2 squared. This is 4, this is 4, we get 8, and r is square root of 8 or 2 square root of 2. I'm assuming by now nobody has any problem with that, okay? So that's pretty straightforward, everybody. What about tan theta? Y over x. Minus 2 over 2, negative 1, and we are in the fourth quadrant. Theta is negative power 4. We discussed the positive in a moment. But so we can write r is 2 square root of 2. Theta is minus power 2, minus power 4. 2 comma negative 2 is the same as 2 square root of 2, r comma minus power 4 theta. If we want to have this positive, we add 2 pi. So if I add 2 pi, or 8 pi over 4, I get 7 pi over 4. So I could write 2 square root of 2 comma 7 power 4. That's the same thing. Transform polar equation r cosine theta equals -2 to an equation in rectangular coordinates and graph. R cosine theta is -2 on the one hand. On the other hand, x is r cosine theta. So that means x must be -2, which is a vertical line. So we go 2 tick marks to the left. This one is the x-intercept as far as the rectangular coordinate is concerned, and we have a vertical line as the answer. Transform the polar equation r equals 2 cosine theta to an equation in rectangular coordinates and graphs. We are going to look at methodologies. When r is given on one side and either sine or cosine on the other side, we remind everybody that x equals r cosine theta, r squared is x squared plus y squared, r is 2 cosine theta for this question. And the technique is to multiply both sides by r, because this becomes r squared. This involves r and cosine. That means it involves x. So let's multiply both sides by r. Replace the r squared with x squared plus y squared. 2 r cosine theta is 2x. And we're going to bring 2x next to x squared. We're going to complete this square. B is -2. B over 2 is -1. Square root is +1. And we're going to add 1 to both sides. Left side is x minus 1 squared plus y squared equals 1. Reminding you, a circle centered at 0, 0 has the equation x squared plus y squared equals r squared. A centered at hk has the equation x minus h squared plus y minus k quantity squared equals r squared. So this one has center at 1, 0. Radius is square root of 1, making it 1. So we're going to put 1, 0 as a center. And please note, I'm going to use 2 tick marks, 1 and 2, to represent 1 because the radius is small. And now we draw. Again, I thought it looks better if I go with 2 tick marks. It's your choice, but if you go with 2 tick marks, you have to let the reader know. Transform the polar form of cosecant theta equals 8. Well, basically we do the same thing. First and foremost, remember cosecant is 1 over sine. So r cosecant theta is the same as r over sine theta. Do the cross product. R is 8 sine theta. Now it's a similar situation to the previous example. The technique is to multiply both sides by r, because this side becomes r squared, this side becomes 8, r sine theta, and they are both familiar. R squared, x squared plus y squared, 8 r sine theta is 8y. So we are going to write x squared and y squared, they add up to r squared. Y is r sine theta. Therefore, r squared 8r equals 8r sine theta becomes this. So that should be pretty straightforward. Now we are going to move the 8y and again complete this square. B is negative 8. B over 2 is negative 4. Square root is positive 16. And we're going to add 16 to both sides. This becomes x squared, y minus 4 quantity squared equals 16 or 4 squared. According to this is a circle centered at 0, 4. R is square root of 16 or 4. Then we stick with one tick mark. So 0, 4. So 1, 2, 3, 4. We go 4 up here and a circle with the radius 4. Or something like this, you can say one tick mark represents true, and then if you want to represent it in that format, but in any event. Identify, graph the equation, and convert to a rectangular equation r equals 4. This is the simplest form, actually, of representing a circle. The technique, square both sides. This becomes r squared. This becomes 16. As you know, r squared is x squared plus y squared. So we are dealing with a circle centered at 0, 0 with the radius 4. 0, 0 is the origin or the pole. What about theta equals 3 pi over 4? When theta has a value that is representing a line, and to understand that, we know tan of theta is y over x, so let's take a tangent of both sides. So tan of the left, tan of theta, is equal to tan of the right, tan of 3 pi over 4. 3 pi over 4 is a common arc. Okay. And tan of pi over 4 is positive 1. 3 pi over 4 is negative 1. So if negative 1 is y over x, y is minus x. So when theta is 3 pi over 4, the line y equals minus x. I hope you remember y equals x is this way, y equals minus x is that way. And there you have it, and you're done. Identify, graph the equation, convert it to rectangular form. Okay. R sine theta equals negative 3. And we know R sine theta is y. Therefore, y equals negative 3, which is a horizontal line. So we locate 0 minus 3, and we draw a horizontal line. Again, this grid is in essence combination of polar coordinate and rectangular coordinate. Our cosine theta, we know it to be x. So x equals 4 is a vertical line. You locate 4, 0, 1, 2, 3, 4, and then draw a vertical line. So a synopsis of what we have covered so far. Theorem. When r equals a, it's a circle. The center is at the pole or the origin with the radius a. When theta equals some angle, the line y equals tan alpha. Let's say this is alpha. Tan alpha times x. For example, theta is pi over 4, tan of pi over 4 times x. That's what we mean. This alpha represents some number in radian or in degrees. Horizontal line, r sine theta equals a, y equals a. Vertical line, r cosine theta equals a, x equals a. All of this, r equals 2a times cosine or sine, positive or negative. All of them happen to be a circle with radius a. Now the center is along the x-axis, polar axis, if we are dealing with cosine, positive on the positive side, negative on the negative side. And it's along the y-axis or theta equals pi over 2. That's if it involves sine. Okay, by the way, the x-axis or the polar axis, the y-axis, theta equals pi over 2. Having said that, let's discuss symmetry in polar coordinates. I hope everybody remembers the symmetry in rectangular coordinate. We say even, remember, f of minus x equals f of x, which means symmetric with respect to the y-axis. Odd, f of minus x is minus f of x, and that's with respect to the origin, right? Remember that? Now let's discuss it for polar. So this is reminding you of what we already know. All right, symmetry with respect to WRT, with respect to the polar axis, x-axis. If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So take a look. So here's the polar axis or the x-axis. Okay, r comma theta, r comma negative theta are the same. That means symmetric with respect to the x-axis, or more precisely polar axis. Symmetry with respect to the line theta equals pi over 2. Theta equals pi over 2 is like the y-axis. See, theta equals pi over 2. If in the polar equation r comma theta can be replaced by r comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2 or y-axis. Let me erase my work. So as you can see here, this distance is theta, everybody. Okay, and this distance is theta. That means this is pi minus theta. That's why r comma theta and r comma pi minus theta are the same. Symmetry with respect to the polar or the origin. If the polar equation r comma theta can be replaced by either negative r comma theta or r comma theta plus pi, the graph is symmetric with respect to the pole. Remember, if this is negative, you can have this to be opposite with that and just add odd multiples of pi. So these two are identical. And so you have to check both. And so r theta, this becomes negative r comma theta. So we want to graph r equals 1 minus cosine theta. So how do we graph a polar graph? Just as we did with trigonometric functions, or even any other type of function. First, we plug some numbers. So we're going to go with easy points first. And by the way, in general, r equals a times 1 plus minus cosine theta, and a is positive. This is a cardioid, looks like a heart, and it passes through the pole when a is positive, larger than 0, in any event. So let's go with this is theta, then 1 minus cosine theta or theta. So let's go with some easy numbers. For example, if I want 0, everybody knows cosine of 0 is 1. So I'm going to plug in a couple of. So if I put 0 here, I get 1 minus cosine 0. 1 minus 1 equal to 0. And therefore, I have 0 here, 0, 0. just as an example. Let's say I'm going to put pi over 6 here. I get 1 minus cosine of pi over 6. I get 1 minus square root of 3 over 2. And I'm going to keep it as an exact. If I put pi over 4, 1 minus cosine of pi over 4, or 1 minus, this was square root of 3, okay? Square root of 2 over 2 here. Now, pi over 3 is easy. Pi over 3 is 1 minus cosine of pi over 3, okay? Which is 1 half. 1 minus 1 half is 1 half, okay? Pi over 2. I hope you see that it's 0, so it gives you 1. 2 pi over 3. 1 minus cosine of 2 pi over 3 is 1 minus negative 1 half, and it gives you 3 halves. Pi, 1 minus cosine of pi is 1 minus negative 1, and it's 2. So we get those, just as an example. The point is, it's very easy to evaluate them and write the pairs. Now, notice some of the pairs I put them in different colors because I'm not going to, for example, try to do this. I'm going to go with the easy one. So I'm going to locate 0, 0, which is the pole. Okay. And by the way, we're going to go with 2 tick marks equals 1 again in this case. So 0, 0. Okay. So I want to go with 1 half pi over 3. And how do I locate that? First, look for pi over 3. Here's pi over 3, this one. And we said 2 tick marks means 1. And pi over 3 is 1 half, so we go with 1 tick mark. So pi over 3 and 1 tick mark. I'm going to go again with the easy one. This one is 1 pi over 2. Pi over 2 is here. Pi over 2. First locate the theta. Pi over 2 is here. And 1, we're going to go with 2 tick marks, 1 and 2. Okay. Then I'm going to go with the easy one. Okay, 3 halves, 2 pi over 3. So let's locate 2 pi over 3. 2 pi over 3 here. 2 pi over 3. And 3 halves, 1.5 times 2, 3. Okay, so 1, 2, 3. Because again, 2 tick marks is 1. 2 comma pi. Pi is this one. 2, we're going to go with 4. We're going to go with 4. 1, 2, 3, 4. And if you put them together, it'll look like this. Now, we can get more points. I'm going to discuss the symmetry to see what happens. And I hope you see that because you're dealing with cosine, and cosine of theta and cosine of minus theta are identical, that makes it symmetric with respect to the x-axis, more specifically, polar axis. So symmetry with respect to WRT, with respect to the polar axis or the x-axis. If you recall, if in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So in essence, it's just by symmetry, I should get something like this. Okay, that's it. But if you want to pick up a few more points, again, I'm going to go with the easy points. 4 pi over 3, I hope you see it's the same as 2 pi over 3 because cosine is negative. There 1 minus half becomes 3 half. 3 pi over 2 is the same as pi over 2 gives you 1 because it's 0. 5 pi over 3, okay? So it's the same as pi over 3 is 1 half because 1 minus 1 half. 2 pi is the same as 0 is 0 because cosine of 0 is 1, 1 minus that is 0. So you have those pairs and you have the entire graph. So pretty straightforward. I hope everybody is okay with that. So that's how polar graphs work. So the synopsis of that: plot pairs, look for symmetry. You should have an easy time graphing it. Now, plot the complex number, 1 plus I, in the complex plane and write it in polar form. Complex numbers, I want to remind you that we normally use A plus BI where I is square root of -1. That's what we mean. And now we're going to use actually x plus yi. It doesn't matter you use this format or this format. So then the rectangular coordinate system. The x-axis is the real axis. The y-axis is the imaginary axis. So here's the synopsis of what we need to do before we work on this. Polar form of a complex number z equals x plus yi is z equals r parentheses cosine theta plus I sine theta. And here's the shorthand notation, r c theta. C stands for cosine, I of course is I, and S stands for sine and theta. So this is a shorthand notation of the same thing. Representing the number by its distance r, which is known as a modulus, from the origin, some distance, and angle theta, or the argument from the positive real axis. What are the key conversions? X r cosine theta, y is r sine theta, r squared is x squared plus y squared, identical to what we have seen. Now the modulus or the magnitude of z is r, or square root of x squared plus y squared, tan theta equals y over x. There's really not much brand new stuff here. So let me erase my work. And so r is, and this is 1 and this is 1i. Please understand, this is, when we say I, this is 1 times I. So x is 1, so is y. Okay. And if you want to plot a point in general, okay, this is the distance r, or the modulus, or the magnitude. This is the argument theta, z is x plus iy, and its complex conjugate. Remember, a plus bi is a minus bi, so z, they call it z star, z bar, z prime, depending on the text, x minus iy, complex conjugate. Okay, so I hope everybody's okay with that. So in this case, 1 to the right, 1 up. And of course, since we're going to go with 2 tick marks, 2 to the right, 2 up, that would be what we are looking for. This is r, and this is theta. And so we are going to say, okay, we know r is square root of x squared plus y squared, which makes it 1 squared plus 1 squared, or simply square root of 2. Tan of theta is y over x. That means 1 over 1, which makes theta pi over 4, 45 degrees. So we have r square root of 2, and we have the angle. Theta is 45 degrees, or pi over 4. So z, which is 1 plus I, is going to use r cis theta, shorthand notation, or times cosine theta plus I sine theta. R is square root of 2, theta is 45 degrees. So 1 plus I is the same as square root of 2 cosine of 45 degrees plus I sine of 45 degrees. So that's pretty straightforward. I hope everybody's okay with that. So we are going to move on, everybody. Write a complex number 4 times cosine 7 pi over 4 plus I sine 7 pi over 4 in rectangular form, and plot the complex number. Well, all we have to do, evaluate the cosine and sine. That's all. 7 pi over 4, this is theta, and reference arc is pi over 4. Cosine, 7 pi over 4 is in the fourth quadrant. Cosine is positive, sine is negative. Both of them are square root of 2 over 2. Cosine positive, sine negative. So you distribute the 4, the 2 goes away. We get 2 square root of 2 minus 2 square root of 2 pi. 7 pi over 4. 2 square root of 2. Square root of 2 is about 1.4 roughly. 2 times that. So roughly. It's 1.41. So 2 times that is about 2.8. So 2.8 to the right and 2.8 down, roughly. Okay. So that's what we get, and hopefully everybody is okay with that. So that's pretty straightforward. Find z times w and z divided by w and leave the answer in polar where z and w are given as follows. Well, how do we perform those operations on polar? When z is given as r cis theta in polar form, and of course we know the relationship between the rectangular and polar is given. Z1, Z2, if you want to multiply it to, it's R1, R2, cis theta 1 plus theta 2. If you want to multiply their magnitude and then add up their modulus, their argument, my apologies. If you're dividing it, divide their magnitude or modulus, and then cis subtract their angles or argument. So having said that, Z times W, we're going to multiply the two. I'm going to multiply these two numbers. So 2 times 2 is 4. And then we're going to add pi over 8 and pi over 10. So 2 times 2, cosine of pi over 8 plus pi over 10, and I sine pi over 8 plus pi over 10. So let's see how we add them up. Let me quickly show you. 8 and 10, common denominator is 40. 40 divided by 8, 5 pi. 4 divided by 10, 4 pi. So we get 9 pi over 40, and of course, this is 4. So that's pretty straightforward. What about division? Let's write the division. Z over W. You just write the first one, you write the second one, and obviously they cancel each other. Cis theta 1 minus theta 2 power 8 minus power 10. Cosine of power 8 minus power 10 plus I sine of power 8 minus power 10. Reminding you, this is 5 pi over 4d. This is 4 pi over 4d. The difference is only 1 pi over 4d. So cosine of pi over 4d plus I sine of pi over 4d. Pretty straightforward, everybody. Write the standard form A plus BI, standard form, rectangular form of square root of 3 cosine of 5 pi over 18 plus I sine of 5 pi over 18 when we want to raise it to the power of 6. In other words, how do we raise this to the power of 6? Here's the methodology. We've already discussed the relationship between the two formats, product, division. Now, how do you raise it to a power? We use the Moir's theorem if n is larger than or equal to 1. When z's are cosine theta plus I sine theta, if you want to raise z to the power of n, you raise r to the power of n, and you multiply the theta by n. That's the methodology. So having said that, let's write this. Z to the power of 6 means this thing to the power of 6, and this thing times n or 6. That's it. Now, square root of 3 to the power of 6 means 3 to the power of 3. And this one, let's do the math here. So 6 cancels out the 8. Now, 5 pi over 3. So 3 cubed obviously is 27. 5 pi over 3. The reference arc is pi over 3. And because this is the fourth quadrant and cosine is positive, cosine of 5 pi over 3 is identical to cosine of pi over 3. But sine is negative in the fourth quadrant, so it's the same as negative sine of pi over 3. So that's why this one we change the sign to negative. Now pi over 3, the cosine is 1/2 and the sine is square root of 3 over 2. So 27 halves minus 27 square root of 3 over 2 times I is the exact and the final answer. Given z equals 1 plus I, find z to the power of 10. Well, first you have to find this one in polar format. Because if you want to raise this to the power of 10, 1 plus I, and you do not change it to a polar format, imagine to the power of 10, it takes quite a few pages. Instead, we're going to take this and convert it to polar format RC theta, and then to the power of 10. And I hope you remember in question number 9, we did this. We calculated this. Okay. So we already have done this. So we are not going to repeat that. But now we have a chance to raise this to the power of 10. So if I want to raise this to the power of 10, I'm going to use de Moivre's theorem, square root of 2 to the power of 10, and then 45 times 10. Z to the power of 10. I'm going to raise this one to the power of 10, and I'm going to multiply 45 degrees by 10. So having said that, obviously this becomes 2 to the power of 5, and this becomes 450 degrees. As you know, 450, okay, this is 32, and this is 360 plus 90. So just use 90. Cosine of 90, 0. Sine, 1. So now it's 32i. In other words, raising z to the power of 10, converting it to a polar and raising it takes just a minute. But if you want to raise 1 plus I to the power of 10, that means you're going to multiply by itself 10 times. It takes a long time to do so.